This question is very interesting. It's about buffers, but also about ratios. Quite like it. So they tell us that the pH is 4.11. Every time that they give you the pH, then you know that you can calculate the concentration of protons. And usually only that is 1 mark. And they give us the Ka, and then we have to find the ratio between the acid and the conjugate base. So we can start by writing the Ka expression. There we go. And then really what we want to find out is this ratio. Any division, any percentage is a ratio. So in this case, this division is a ratio, but we want to have it the other way around. We want to have the acid at the top, and the acid should be divided by the conjugate base. So we can do that if we rearrange the equation. So we are going to move this to the other side. It's dividing here, so it will go there multiplying. This is multiplying here, so it will go to the other side dividing. And Ka will go to the other side dividing. So what we are going to get is there we go, that equals the concentration of products over the Ka. Um, this is really what we want to find out. That's what they are asking us. So the concentration of protons is going to be 10 to the power of minus 4.11. All of that divided by the Ka, which is 1.74 times 10 to the minus 5. So that equals that equals 4.46 to three significant figures. So that means the ratio is 4.46 to 1. So for every 4.46 moles of the acid, we have 1 mole of the conjugate base. Let's look now at question B. Again, they give us the pH, so we can find the concentration of protons, and they gave us the ratio as well, 20 to 1. Alright, so again, we are going to need the Ka expression. For any question about buffers or weak acids, we always need the Ka expression there. So in this case, they ask us to calculate Ka for carbonic acid. So we know that in healthy blood, the Ka is going to be the concentration of protons, which is 10 to the power of minus 7.4 times concentration of conjugate base over acid. And they give us the ratio of 20 to 1. So that's 20 to 1. And that way we can calculate Ka. So that would be 7.962 times 10 to the power of minus 7. The units would be mole per meter cube. And now we know Ka, that's question 1. Question 2, they want to calculate now the ratio when the pH is 7.20. So the ratio of, then it would be this ratio again, the one that we calculated before, this one here. So again, the ratio, oh sorry, and this is, in this case, we are not using ethanoic acid, we are using hydrogen carbonate, which is HCO3 minus over carbonic acid, which is H2CO3. But again, it's the conjugate base over the acid. So conjugate base over acid equals Ka divided by concentration of products. We know the Ka from before, which was 7.962 times 10 to the power of minus 7 divided by the concentration of protons, which in this case it's going to be 10 to the power of minus 7.20, as we are talking about the patient. When we do this calculation, we get 12.62. So for every 1 molecule of carbonic acid, we have 12.62 of hydrogen carbonate. And that would be the answer to this question.